All right, review for test number 2, which is all of quadratics and exponential functions. So first, starting with number 1, graphing a quadratic. So in order to graph a quadratic, what you need to do is plug that function into the y equals on your calculator. So the way that you would do that, and I'm going to try and show you my calculator here, okay, is you would start by pressing y equals, clear out anything that might be in there, and type in the function as you see it. So it starts with negative. Negative is this button right down here. So negative. Then I type x, which is right here. Squared is the button right here. Make sure you press x before you press the x squared button. I know this button says x squared, but all it does is it puts the squared on that x. Then you're going to type plus 4x minus 3. Okay, so here's what it should look like when you type it in. So I can't turn mine quite upright because of the way my phone is set up to record this. So if you want to see what the graph is supposed to look like, what you're going to press is graph. So there's what your parabola is supposed to look like. Remember, if it's a negative x squared, it's going to be a negative parabola. That's where that frowny face comes from. But ultimately what you need is the set of points, and you get that by hitting second graph. When I hit second graph, there's my list of points. Now I like how my table showed up to start because it started with -3, -24. If you look at your grid, it goes out to 10 in all directions, -10 if you're talking about left and down. There is no way that I can graph that -24. So if you're trying to find which points you want to graph, you're really just picking the points that are under 10. So here's the table that I chose from my calculator. I started at, here's my XY table. I started at an X value of -1 because it was the first Y value that was under 10. And then I kept going and I copied my table like so. Actually, I believe that was a -8. I'm sorry. It's -1, -8. Then 0, -3, 1, 0. Then I have the point 2, 1, 3, 0. 4, -3, and 5, -8. You do not need to copy your table. You just need to find that ideal section on your table because those are the points that are plottable. So now I'm going to plot them. -1, -8 means I go left 1 on my x-axis and down 8 on my y-axis, leaving me right here. Then 0, -3 means I don't go left or right at all, and I just go down 3. Then 1, 0 is here, 2, 1 is here, 3, 0, then 4, -3, and 5, -8. Now parabola is a U-shaped graph, so you want to connect them in a curve. Please don't connect the dots in a bunch of straight lines. Make it a curve, and it does continue down forever. So I'm going to put arrows on the end to note that. Okay, once you have it graphed, you need to complete the table based on the graph. Now we already talked about how it's a frowny face. It's pointing down, so it is a negative parabola, so this is going to be negative. And you need to know all of the vocabulary for these. The vertex is the turning point. My turning point is right here where the parabola turns, and that is the coordinate point 2, 1. Remember, it's got to be x, y. That goes right to up 1, so it's the point 2, 1. X-intercepts, roots, and zeros are all at the same place on the graph. It's where it crosses the x-axis, specifically right here and right here. X-intercepts needs to be written as points. Your roots and zeros are just the x values, but they are still the same place on the graph. So right here on the graph is +1. Right here on the graph is 3. So if I'm writing those as points, it's the point 1, 0 and 3, 0. The roots and zeros just being the x values would just be x equals 1 and x equals 3. Okay, now because my x-intercepts are written as points, my y-intercept also needs to be written as a point, and it's where it crosses the y axis. My y-axis crossing point is right here where I just put a square, and it is the point 0, negative 3, because I don't go right or left at all, so x is 0, and then I go down 3. The axis of symmetry is like your line of reflection, and I'm just going to draw that in. It's almost like the line where if you were to cut the parabola in half, it would be the same exact piece on the left and the right of your axis of symmetry. Now your axis of symmetry is a vertical line that goes through the value x equals 2. Here's that value of 2. It goes through x equals 2 the whole way down. The entire line is going through x equals 2. Here's where it starts to get a little bit tricky. Okay, for increasing interval, that's where the graph is going up. Decreasing is where the graph is going down. Now, if you're looking at the graph, it might seem like it's always going down because both arrows are pointing down. However, you have to read it left to right. So if I start over here on the very, very left side, right here, it's going up at this point. It's going up, 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 up until it reaches the vertex or the turning point, like the top of a mountain. Once you reach the top of the mountain, that's where it starts decreasing or going down. But you need to state the interval. Over here where I started, all the way to the left, is negative infinity. When you're talking about an arrow pointing all the way to the left, that's negative infinity. And then up here where it stopped increasing is at 2, the x value of 2. So my increasing interval is negative infinity through 2. Now, if it stopped increasing at 2, that means it had to have started decreasing at 2. So 2 through, and then if I follow that arrow I drew again, right here, it's going down, 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 and technically over to the right, 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 forever and ever, and that is called infinity. When you're talking about going to the right for infinity, it's positive, because all x values to the right are positive, and you always use x values for your intervals. That being said, now my interval where the graph is positive, I'm just going to switch up my color for a second here. A positive is where it's above the x-axis. My parabola was above the x-axis from here to here. That's it. It's a very, very tiny piece, but I need to state which x values it was above. This x value right here is 1. This x value right here is 3. So it was only positive from 1 through 3. Okay, now for negative, it was negative much longer. It was negative starting here and up, and then it was negative again from here and down. Now remember, we said that negative infinity is where it's starting then, and then all the way through this value where it started being positive. So it was negative from negative infinity through 1. That's this first circle right here. Negative infinity down here through 1. Then it was positive from 1 to 3. And then at 3 it stopped being positive. Well, if it stopped being positive, that's where it has to start being negative. So from 3, it started being negative. Through, this arrow is again pointing all the way down and to the right to positive infinity. Notice, increasing and decreasing are opposites of each other. It was increasing from negative infinity through 2, and if it stopped increasing at 2, it had to start decreasing at 2 through infinity. It's the whole interval. Then for positive and negative, same idea. If I look at negative first, from negative infinity through 1, it was negative, and then if it stopped being negative at 1, it had to start being positive at 1 through 3. And if it stopped being positive at 3, that means it started being negative again at 3 through positive infinity. All right, for number 2, same idea with how to graph it. You start with the y equals button on your calculator. You type in 1/2, or you can use 0.5 if you prefer, x squared minus 4x plus 6, and you find the ideal points in your table. By ideal points, I mean the numbers that are less than 10. So first is 0, 6. Then 2, 0, then 4, negative 2, then 6, 0, then 8, 6. And we're only 5. So then you go ahead and you plot those 5 points on your graph. So on my graph, I start at 0, 6, which is right here. 2, 0 is here. 4, negative 2. 6, 0, and 8, 6. Again, it's a parabola, so try and curve it as you connect it. I'm going to do my best. Oh, I missed one of them. Oh, I missed two of them. I'm going to start that one over. All right, let's try again. Oh, missed it again. We'll just make it a little bit bigger and pretend I never missed it. And I need an arrow. So this one continues up forever, which makes it a positive parabola. It's a happy face. So over here on my table, I'm going to start by saying it is positive. Remember, if I'm going too quick for you on this video, please just pause it, finish your graph, and then continue on. Okay. If we recall from number 1, the vertex is the turning point. My turning point is right here at the point 4, negative 2. I know mine kind of looks like negative 3, but it is this point up here at 4, negative 2. Straight from the table, right here in the center. X-intercepts and roots and zeros are at the same spot on the graph. It's where it crosses the x-axis. They're also known as the solutions. Okay, but these have to be written as points. And then the roots and the zeros are just your x values. Okay, so the points that I just circled on my x-axis are 2, 0 and 6, 0. Again, straight from the table if that table helps you. And then the x values are just 2 and 6. So x equals 2 and x equals 6. Now, since my x-intercepts were points, again, my y-intercept is also going to be a point, and I'm going to box it in. It's where I cross the y-axis, and I need to write it as a point like I just said, which is the point 0, 6. Okay. The axis of symmetry, okay, this right here, is my axis of symmetry. It's the line that I could cut down to chop my parabola perfectly in half. And it's always going to go through one specific x value. So I'm going to write x equals, and that x value that it goes through is 4. So my axis of symmetry is x equals 4. And you need that x equals to define the line. That vertical line is x equals 4. All right, now because this one is a positive parabola, it does look like it's always increasing because the arrows are pointing up, but it's not always increasing when I trace it from left to right. Left to right, it's starting by decreasing, decreasing, decreasing until here, and then it starts increasing from here up. So my decreasing interval starts at negative infinity. So I'm going to do that one first. Okay, up here, even though it's up, we're talking about the left. You're always using x values for your intervals. So over there, even though it's pointing up and left. So my decreasing interval starts at negative infinity. And then it's decreasing, decreasing, decreasing until right here, that little bottom pit, the vertex where it turns and starts increasing. But this x value right here is 4. So negative infinity through 4 is when it's decreasing. Now, like we said in number 1, if it stops decreasing at 4, that means it starts increasing at 4. So 4 through, and then if I trace this line again that I drew right here, up and all the way to the right. I don't really care about the up part. It's all about the right. If it's going all the way to the right forever and ever and ever, that's through positive infinity, that it's increasing. It never ever stops increasing after 4. Now, just like number 1 for this positive and negative, I'm going to switch up my color. Positive is where it's above the x-axis. Above the x-axis has 2 different intervals. This piece right here and this piece right here. Negative is just this tiny little section right here where it's below the x-axis is from here to here. I'm going to do that one first. Okay, so it is negative where it's below, where I'm tracing right here. From this x value, which is 2, to this x value, which is 6. So it's negative from 2 through 6. And that's it. It's never negative again. It's positive in 2 other intervals. So like we said, it's starting to be it's starting to be positive right here, which we already called negative infinity. So from negative infinity through a certain number, it's positive. Well, it's this circle right here. So negative infinity is up there through this value right here where it hits the x-axis, which is 2, which makes sense. If it's positive from negative infinity through 2, it had to start being negative at 2, and it did. Okay, the interval that the graph is positive is negative infinity through 2. Then from 2 to 6, it was negative, and then that means at 6, it started being positive again through, and if you notice, it never ever comes back down. So it's positive for the rest of the way, all the way to positive infinity. All right, so that is it for the first page. I'm going to flip. So like I told you, for solving quadratics, you can either solve a quadratic by factoring it and doing a t-chart, or you can use the quadratic formula. If you don't like factoring, I told you the quadratic formula isn't out for solving. However, if the directions say factor, especially if it says factor with an underline like number 3 does, you have to factor. And there is no teeing it up, it's just factoring. So you need to know all of your different types of methods of factoring in order to do these 3 parts. Okay, so number 3, part A, if I look at it, hopefully we remember that the first type of factoring you're supposed to look for is a GCF. Part A does not have a GCF, so the next thing I do is I count the terms, and there are 3. If there's 3 terms, that means it's a trinomial. But you have to see which type of trinomial it is. A trinomial easy has a 1 in front of the x squared. A trinomial AC has any other number in front of an x squared that's not a 1. This one has a 15, so it's got to be trinomial AC. So tri-AC is the method that I'm going to use for this one. So for trinomial AC, what you do is you start by multiplying A and C together. Now it's 15 times a negative 1. That gets me negative 15. What you're going to do is list the factors first of just positive 15 off to the side. So it's 1 and 15, and I also have 3 and 5. Now, since I'm trying to multiply to a negative 15, I know that my factors have to be one positive number and one negative number. And I also need to consider my goal. My goal is to pick one of those 2 pairs that also adds to the middle number. And my middle number is 2. So the only way that's going to work is if I use 3 and 5 and I make the 3 negative. Do a quick little double check. Negative 3 times 5 is negative 15. And negative 3 plus 5 is that positive 2 that I have in the middle there. Now, this isn't the easy method. My answer is not x minus 3, x plus 5. What you have to do at this point for AC is set up a grouping problem. And the way that you do that is you first bring down your first term, so 15x squared comes down. You split up the middle term into minus 3x plus 5x. I didn't change the value of anything, I just expanded it. We're used to going the other way and simplifying and combining negative 3 and 5, but you're expanding it to get 4 terms. Then you bring down the minus 1 to get that 4th term. And again, the reason you're expanding it is because now you have 4 terms and you're able to use the grouping method. So for the grouping method, what you do is you take your first 2 terms and group them together, and you take your second 2 terms and group them together, making sure you get the sign in front of the 3rd term in your second group. Now, as you're doing the grouping method, what you're going to do is GCF each group as if it's its own type of factoring. So my first group right here has a GCF of 3x. So I'm going to divide both of them by 3x and put the 3x out in front. Now 15x squared divided by 3x, take it piece by piece. 15 divided by 3 is 5, and x squared divided by x is x. Then I do 3x divided by 3x. Well, if everything cancels, it doesn't just go away. It ends up being a minus 1. 3x divided by 3x is 1. Now here's where it gets a little bit tricky. My second group is 5x minus 1. There really is no GCF other than 1. So my GCF is just a 1, and I put that 1 out in front, which makes dividing a little bit easier. 5x divided by 1 is 5x, and negative 1 divided by 1 is a minus 1. Now what's kind of nice about grouping is that once you get to this step, these need to match up. If they don't match up, you've done something wrong. We have not done something wrong because they match up. So since they match up, I'm able to go down to my answer. They match up, so you bring it down in your answer as though it's its own GCF in the whole problem. If you take out the 5x minus 1 from everything above, you're left with 3x and a 1. So 3x plus 1 is your other factor, and I am done factoring this. If you want to put this in the other order, like so, both of these are acceptable answers. That's trinomial AC. Part B. When I look at B, again, the first type of factoring you want to look for is a GCF. This one does have a GCF, and it's kind of a tricky GCF. The GCF on your test will be a little bit easier, I promise, but the GCF of this one is 18. So I'm going to divide both of these by 18. Remember, when you're doing GCF, you put that GCF out in front and you follow it with parentheses, and then you divide. These 18s cancel, and I'm left with x squared. That 72 divided by 18 is going to be a minus 4. Make sure you bring down that minus, and then the y squared comes down. Now, I don't know if you remember what we did in class, but when you are factoring completely, you have to see if anything can be factored again. In part A, this 5x minus 1 and this 3x plus 1 could not be factored again. But in part B, I've GCF'd, and I can actually factor this that's left again. It has two terms, and if you notice, it does follow my DOPS, or my difference of perfect squares, criteria. It is subtraction, which is what the difference stands for, and those are both perfect squares. So to do DOPS, I start by taking the square root of each of those terms, and I bring them down. So the square root of x squared is x, and the square root of 4y squared is a 2y. Now for DOPS, it's always going to be x minus 2y, and then I write it again with a plus x plus 2y, and don't forget to bring down that 18. It is part of your final answer. Now again, same thing goes as like I said with A, you can change the order of those. So if you do 18, then x plus 2y, then x minus 2y, you will still be correct. For C, start right away by seeing if there's a GCF between the whole thing, and there is not. So then I count my terms. This one has 4 terms, so that's grouping. I start by grouping the first 2 terms together, and then the second 2 terms together, and I GCF both of them, just like I used the grouping method in A. So I'm going to go through this one a little bit faster. The GCF of my first group is 3x squared. And I put that 3x squared out in front. I'm just scooting it over because I don't have a lot of space there. These 3's cancel, and x cubed divided by x squared is x. These x squareds cancel, and negative 6 divided by 3 is a negative 2. In my second group, my GCF is a 2, so I put that 2 out in front. These 2's cancel, and I'm left with x minus 4 divided by 2 is 2. Thank goodness these match up. That means I've done it correctly, and I bring that down in my answer. And my other factor is what is remaining, 3x squared plus 2. And again, just like I said in A, you could write those in the opposite order and put the 3x squared plus 2, then the x minus 2. Now, just a reminder that for all 3 of these, factoring is undoing the distributive property. And I'm going to say that again because it's so important. Factoring is undoing the distributive property, which means that for A, B, and C, I can go through and double distribute all 3 of them, and I should end up with what I started with as a check. You don't have to do it. This is it. Those are my answers. But if I wanted to check them, I would double distribute them, and it should get me back what I started with. All right, number 4. Is what we just recently learned. It says if $290 is invested in a savings account that earns, so gains, 4% interest per year, determine the amount in the account at the end of 11 years, round to the nearest dollar. So this is the formula that's given to you on your formula sheet. You don't need to memorize it. All you need to remember is that earns means you're going to use the plus version. So it's going to be A equals P times 1 plus R to the T. You would only use minus if it was a decaying problem, or it's a decreasing or losing interest. Okay, but this one's earned, so it's plus. Now, It tells me what I'm starting with, which is $290. The letter that you're starting with is P, so P is 290. R is always going to be your rate, but you have to write that percentage as a decimal. So yes, it is 4%, but that is equal to 0.04, and that's what you're going to plug in. You don't plug in 4%, you plug in 0.04. And the last letter that I have is T, and T is your time, so it is 11 years. It was 4% interest per year, and 11 years they match up, so that is all good. That tells me that A is the only number I don't have, so that's what I'm trying to find. So I'm going to leave A as A in my formula and plug everything else in. 290 times 1 plus 0.04 raised to the 11th. And just like we practiced in class, you're going to plug that in exactly how you see it, parentheses and all, and you should get 446.441676. Now it tells me to round to the nearest dollar. That means no change at all, but you still need to look at this digit to see if it's going to bump it up to 447. That 4 does not have enough power to bump it up, so my final answer is just going to be $446 in the savings account after 11 years. Next, use exponent rules to simplify the following. So for exponent rules, the first one is division. When you divide, you do still divide those coefficients or the numbers in front of the variables. So I start with 12 divided by 6, which is 2. Then I know that my rule for dividing variables is to subtract the exponents. So x to the 12th divided by x to the 6th is going to be x to the 6th because 12 minus 6 gets me 6, and I'm done. B is a little bit trickier because of the idea of the parentheses. Everything in the parentheses is being raised to the third power, including the 2. So this can also be rewritten as 2 raised to the third, and that x squared is also being raised to the third. Now 2 to the third can either just be plugged into the calculator, or you can do 2 to the third in your head by doing 2 times 2 times 2. You get 8. Then the x squared being raised to the third power is the power to a power rule, which means I need to multiply these, and I get x to the 6th again. 2 times 3 is 6. So 8x to the 6th is my final answer for B. For C, be very, very careful. Yes, anything to the 0 power is 1, but only the x is being raised to the 0 power in this problem, not the 3. If the 3 was also being raised to the 0, it would look like this, and your answer would be 1. But this one, the 3 is not in the parentheses, so the 3 comes down, and x to the 0 is 1. So that comes down, but my final answer ends up being 3, because only the x to the 0 was 1. The 3 came down, so 3 times 1 gets me 3. Okay, for part D, I have x squared divided by x to the 5th. When I'm dividing variables, I subtract the exponents, and it's top minus bottom. So 2 minus 5 ends up getting me x to the negative third. Now, I know that I'm not done because there's another rule that applies to that, and it's the negative exponent rule. Here's a reminder of that one. You always want to turn it into a fraction, either on paper or in your head, because your goal to get rid of that negative exponent is to take the reciprocal of that fraction or flip it, so it would become 1 over x, and then that makes your exponent positive. This is your answer to D. You flip it and make the exponent positive, so it's 1 over x to the third. All right, for E, yes, it is division. However, you have to simplify the bottom first before you can start dividing, because I'm not done simplifying on the bottom in order to be able to divide. The top, however, there's nothing you can do to that. So I'm going to leave that as x to the negative second, y to the fourth over. Now on the bottom, both the x to the negative third and the y are being squared. When you have a power to a power, you multiply. So this x to the negative third is being raised to the second power, which means I multiply those exponents. Negative 3 times 2 is a negative 6. This y has an imaginary exponent of 1. If I just do that 1 times 2 for my power to a power rule, it ends up being y squared. And I'm not done. Okay, but now I'm ready to divide because I simplified the bottom enough to divide because there's nothing now that I can do to the bottom. I'm ready to divide. And this one's one of the trickier ones for dividing because of the negatives. If I have x to the negative 2 divided by x to the negative 6, I have to subtract my exponents. But if I do negative 2 minus a negative 6, you have to watch out for this. This is going to become a plus. Negative 2 minus a negative 6 is actually negative 2 plus 6, which is x to the 4th. And then y is a little bit easier. Y to the 4th divided by y squared, I do 4 minus 2, and I get y squared. So x to the 4th, y squared. Okay, f is the exact same one we did in class. It follows 4 exponent rules. Same idea as e. You can't divide yet until you simplify. And this one can be simplified on the top and the bottom. So I'm going to start on the top. X cubed times x to the 4th means I add my exponents, so that gets me x to the 7th over. On the bottom, I have a power to a power. X to the 5th raised to the 2nd. That means I multiply my powers and I get x to the 10th. Now that I've simplified the top and the bottom, I am ready to divide. And then when I divide, I do top minus bottom. So 7 minus 10 is a negative 3. So now I'm at x to the negative 3rd. That was the third rule that I've used. And I'm still not done because of that negative exponent. I need to take care of that just like I did in D. I'm at this exact same step that I was at in D, where I want to put it over a 1 so that I can flip it. And when I flip it, I get 1 over x, and my exponent becomes a positive 3. All right, next page. Here we go. Number 6, a little bit easier. What are the solutions of the following parabola? It's already graphed. You just need to know that solutions are where the graph, or where the parabola, crosses the x-axis. Because the x-axis is where y is equal to 0. So all you need to do is find your x-intercepts, your roots, your zeros. That's it. These 2 points right here where I just circled in are x equals 1 and x equals 5. All right, number 7. The population of Red Hook is growing at a rate of 3.5% per year. If its current population is 12,500, in how many years to the nearest year will the population exceed 20,000? Okay, because it's talking about growing at a certain rate, it's that same formula we used a few problems ago, and it's growing, so I'm again using plus. So it's A equals P times 1 plus R to the T. And just a reminder, it's on your formula sheet. You don't need to memorize that one. What you do need to memorize about the formula is where everything goes. And if you look at the back of your review packet right now, you do have a copy of the exact formula sheet you're going to get on the test. And underneath this formula, it does tell you what each letter stands for. It says A is the final amount, P is the initial amount, R is the rate written as a decimal, and T is the time. So as long as you know how to pick out that information and use the formula accordingly, you should be fine. So A was the final amount. If I'm looking at this, it wants to know how many years it will take for the population to exceed 20,000. Again, we'll talk about that exceed in a little bit, but for now, 20,000 is the end game here. That's where we're trying to reach. Where we started would be the current population, and that's going to be P. So 12,500 is the starting amount. Now all I need is R and T. Well, R is my rate written as a decimal. Now, it looks like the percentage is already a decimal. It says 3.5%, but I have to get rid of that percent symbol by either dividing that percentage by 100 or moving the decimal point 2 places to the left. I would end up with 0.035 as my R to be plugged in. Now, if I read through the problem again to try and find the time, it says, in how many years? That's what it's asking me to find. T is now what I'm trying to find. So T is just going to stay T, and I'm going to plug everything else in. So in place of A will be 20,000 That's equal to 12,500 times 1 plus 0.035, and that's raised to the t. Now, because the letter that I'm trying to find is in the exponent, that makes this an exponential function. Remember we said in class, exponential has x in the exponent. Even though this is a t, it's still the same idea. So in order to solve this problem, I need to use logs. Now, like we said in class, you can't take the log of both sides until what's being raised to the variable is by itself. What's being raised to the variable here is this piece that I just circled. That 12,500 is not being raised because it's not in the parentheses. So I can't take the log of both sides until that 12,500 is gone. And right now it's being multiplied. So to get rid of it, I'm going to divide both sides by 12,500. To get rid of it, those will cancel. If I do 20,000 divided by 12,500 in my calculator, I get 1.6, which is nice. And then that's going to be equal to, if I simplify this, it's 1.035 to the t. And now you're set to use logs. You start by taking the log of both sides. So the log of 1.6 is equal to the log of 1.035 to the t. Now the whole point in taking the log of both sides was to get that variable out of the exponent. You're going to take that variable and you're going to bring it down to the front of the log. On the right side, because that's where the variable is for this one. So I'm just going to scoot this on up over here, and I have the log of 1.6 equals now t log of 1.035. And then we're almost done here. If I'm trying to get t by itself, and there's nothing between the t and the log of 1.035, that means they're being multiplied. So to get rid of that log of 1.035, I'm going to divide by the log of 1.035 on both sides. So that these cancel and you're just left with t over here. Now remember, when you're plugging logs into your calculator like this, you press the log button and it gives you an open parentheses. You type in 1.6 and then you have to close your parentheses. Then hit divide. Divide log opens them, 1.035, close them, and then press equals. You should get 13.66233. Reminder, if you can't find the log button, it is right next to the 7. It says log. Your decimal also might be a little bit longer than mine. My calculator rounded it a little bit sooner. It's okay if it's a little bit longer. Okay, now, that number that we just found, that 13.66233, etc., is how long this situation will take for that current 12,500 population to reach 20,000 people, I'm assuming. It's going to take about 13.66233 years to reach that. So if it's asking for the whole year, because it says to the nearest year that it will take to exceed that, it's not going to be 13. It has to take 14. At 13 years, it's not quite at 20,000 yet. It's got to round up. So it's 14 years when I'm rounding to the nearest year that it will take for this population to exceed 20,000. Right, now number 8. Same type of problem for number 8. We're talking about a population of 50 fruit flies is increasing, so it's a plus again in my formula at a rate of 6% per day. Determine the number of days it will take for the fruit fly population to double. Now for this one, it does give me an ending amount. It's just kind of hidden in there. It wants to know how long it's going to take. So again, I'm finding t for it to take that 50 initial fruit flies to double. My ending amount is going to be double 50. Double 50 is just 100. So A is 100. P is your initial amount, so P is going to be what you started with, which was 50. And then again, like we said, we're finding T because it says how many days, or determine the number of days. So T is what I'm trying to find. And R is 6%, but you need to write it as a decimal. So either divide it by 100 or move the decimal point left 2 places, you get 0.06. So I'm going to plug it in just like I did for number 7. I have A equals P times 1 plus R to the T. A is 100, P is 50 times 1 plus 0.06, and I leave the T alone. Now again, similar, very, very similar to number 7, I'm trying to find the variable in the exponent, so I need to use logs again because I'm solving an exponential function. I cannot take the log of both sides until what's being raised to the T, which is 1 plus 0.06, is by itself. The 50's in the way. I can't take the log until the 50's gone and it's being multiplied, so to get rid of it, I divide both sides by 50. So 100 divided by 50 is 2. 1 plus 0.06 is just 1.06 to the T, and that looks a heck of a lot easier as of right now. Now to get that T out of the exponent, here's why I need logs. So on both sides, I'm going to write the word log in front of what's already there. Log of 2 is equal to the log of 1.06 to the T. And the whole purpose of taking the log was to move the T out of the exponent. So I'm going to take that T and move it down. So now I have the log of 2 equals T log of 1.06. Your goal is to get T by itself. T is being multiplied by the log of 1.06. So to get rid of the log of 1.06, I divide by the log of 1.06. That'll get T by itself over here. And remember, like I said before, you're going to press log. It'll give you an open parentheses. You type in 2, and then you have to close your parentheses. Then click divided by. Press log. It'll give you parentheses. Type in 1.06. Close your parentheses. You should get 11.895661. And again, you might have a couple of numbers after that. And my calculator rounded it a bit early. In the direction, it said determine the number of days. I should have added in there to round it to the nearest whole number, but this is approximately 12 days. All right, next page. Number 9, a rocket is fired upwards with an initial velocity of 112 feet per second. Height in feet above the ground as a function of time in seconds since it was fired is given by the equation h of t, which remember just means y, is equal to negative 16t squared plus 112t. Algebraically determine the time when the rocket reaches the ground. If it's asking me to determine the time, that means find t or solve for t. Which means if I'm trying to solve for t, I need to plug something in for the height. The height is h of t. Now, when it reaches the ground, the height is 0. So what it's telling me to do is get rid of this h of t and plug in a 0. So my new equation, when I substitute that 0 in, is negative 16t squared plus 112t equals 0. Now, this is a quadratic. How do I know this is a quadratic? Because there's a t squared and there's a t. There's 2 different ways that I can solve this. I can solve this by factoring and teeing it up, or I can use the quadratic formula. I'm going to use the factoring and teeing it up method. If you want to try the quadratic formula, I'm just going to give you a little hint. A is always the number in front of your x squared. In this case, it's t squared, so A would be negative 16. B is always the number in front of x. Again, in this case, it would be t, so B is 112, which is why I wouldn't want to use it as a big number. And then a lot of people run into a problem with c. There's no c there, so that means that c is 0. So if you want to try the quadratic formula and you're more comfortable with that, by all means, there's your a, b, and c. For factoring this, the type of factoring you always look for first, and the type of factoring that actually applies here is GCF. The GCF of this is negative 16t, so I'm going to divide both of these terms by negative 16t, and I put that out in front. Well, these negative 16's cancel, and t squared divided by t is t, and then positive 112 divided by negative 16 is going to be a minus 7, and those t's cancel, and that's equal to 0. Now this t minus 7, I should check to see if it factors again, but it doesn't. So at this point, I'm already set to tee it up. So negative 16t equals 0, and t minus 7 equals 0. To solve this side, I divide by -16 to get rid of that, and I just get t equals 0. On this side, I add 7 to both sides, and I get t equals 7. Now what that tells me is that it is at the ground at 0 seconds and at 7 seconds. But this problem is asking me for when it reaches the ground. That means it came up and it reached the ground at some number. 0 seconds is when it started. So my answer for where it reached the ground is 7 seconds. For number 10, graph y equals 2 to the x, which is an exponential function because x is in the exponent, and determine the asymptote of the graph. So in order to graph a function that's an exponential function, you're going to use the same method that you would for a quadratic, where you go to the y equals in your calculator and you type this in. So I'm going to show you real quick in the y equals how you would type this in. So you go to your y equals, you clear it out. This one is 2 raised to the x, so you're going to hit 2. Raised to this little caret button right here, and when you do that, it's going to bring you up to the x, or it's going to show the caret depending on what calculator you have, but either way, the next thing you press is x, and that's it. If you want to see what it looks like, you hit graph, which is helpful. That's what your graph is supposed to look like when you're done, but ultimately you want to hit second graph to get your list of points. Now I know there's a lot of decimals, and if you keep going up, your decimals are just going to get smaller and smaller and smaller. That -4 right there means that you take this decimal point and you move it left 4 places. It makes it a really small decimal. Ooh, sorry. Okay, so ultimately what I have here is a table. You can take some of your decimals, but I'm going to pull this out. Okay, because I know you guys know how to plot points. Those are the decimals that were plottable. Anything smaller than that really just starts to get really, really tiny. But what that's showing me is this piece right here. I'm going to try and point to it as best as I can. This right here, as it's going down and down and down, and the decimal's getting smaller and smaller and smaller, it's telling you that it's getting so close to the x-axis, but it never, ever touches it. It never actually becomes 0. They would sooner hit the decimal point, 0.0000000000007, before it actually hits 0. It's the smallest possible decimal. If you were to zoom in, you would see it getting closer and closer, but we're a little bit zoomed out, and you can kind of see it getting closer, but not exactly. That's the definition of an asymptote. Okay, so if you need to pause it right now and take a second to graph this, go ahead. I'm going to move on to part B. So B says, describe what it means to be an asymptote. Well, we just kind of said it, but an asymptote is the line. Asymptote is the line that a graph approaches, meaning it gets very close to it, but never actually touches. The line that a graph approaches but never actually touches. Then it says, and then state what this asymptote of the above graph is. Well, this right here that I'm highlighting or drawing over is the line that the graph's getting really close to, but never touching. Now the equation of that line, you have to be careful whether I know it's 0. Okay, it's going along 0, it's my x-axis. But even though it's my x-axis, it's not where x is 0, it's where y is 0. It's going through this y value of 0. This is where y is 0, and it's going through that. The equation of this line is y equals 0. And that's your asymptote. All right, here we go. With 11 through 18. It's really crucial that you know this because it's going to be set up like this on your test as well. For 11, just not as many questions. For 11 through 18, all the directions say is solve the following, round to the nearest tenth if necessary. For 11 through 18, there's 3 different types of functions. There's linear, which is what we started the semester with. There's quadratics, which means there's an x squared, and there's exponential, which means x is in the exponent. If you need to write those for yourself, write them down. I'll say it again real quick. Linear just has an x. Quadratics has an x squared. Exponential means x is in the exponent. Now they're all mixed up, which means that you need to be able to decipher which method to use when you're given a specific type of function. So when I look at 11, it says 3x squared minus 48 is equal to 18x. That I can tell right off the bat is a quadratic. The reason that I know that that is a quadratic is because it has an x squared in it. So there's two different types of solving that I can do. I can either try to factor it and tee it up, or I can use the quadratic formula. On my key online, I have both methods. I'm going to go through the factoring and teeing it up method. I'll do the quadratic formula a little bit later for one that doesn't factor, so you'll see how to do it then, but I want to go over how to do it with factoring and teeing it up for this one. So I'm kind of giving you a hint that it does factor. During your test, you're not going to know whether it factors or not, so if you want to try and use the factoring method, you just have to see if it factors first. Some people might prefer the quadratic formula because you don't have to worry about that. It's completely up to you. But whichever method you choose to use for solving a quadratic, one thing stays the same no matter what, and it's that you have to be equal to 0 before you can start. And you also have to be in the ax squared plus bx plus c form, which means highest exponent to lowest exponent. So when I'm looking at number 11, I see that it's equal to 18x. That's a big no-no. I need to be equal to 0. Since it's a positive 18x, to get it to the other side, I'm going to subtract 18x. Now the reason that I brought up the order right away is because I need to know what order to write these in. My highest exponent is 3x squared. Then I have my x term, which is a minus 18x, and then the minus 48 comes down, and now it's equal to 0. So I'm good to start factoring, or if you're using the quadratic formula, you're good to start using that. So for factoring, the first type of factoring you always look for is a GCF, and this one does have one. It's 3. Not 3x because only the first terms have an x, it's just 3. 3x squared divided by 3, the 3's will cancel and leave me with an x squared. Negative 18x divided by 3 is a minus 6 and the x comes down, and then negative 48 divided by 3 is a minus 16, and that's equal to 0. You know, you have to factor completely. I just GCF'd, and now I have to see if this can be factored. It has 1, 2, 3 terms, so it's a trinomial, and this one's an easy trinomial because there's a 1 in front. That's why it helps you to take out a GCF first. If I would have started from scratch without a GCF, it would have been an AC trinomial with big, big numbers. No one wants to work with those. The smaller, the better. Okay, so x squared minus 6x minus 16 is the easy trinomial that I'm working with. So I'm going to start by listing the factors of 16 off to the side, keeping in mind that I'm trying to multiply to a negative 16. So I have 1 and 16, 2 and 8, and 4 and 4. Now again, I'm multiplying to a negative 16, which means my factors have to be 1 positive and 1 negative, and it's adding to a negative 6. So the pair that I'm going to use is a positive 2 and a negative 8, because 2 times negative 8 is negative 16, and 2 plus negative 8 is a negative 6. Now because this is the easy method, all I have to do is write it like this: x plus 2, x minus 8, and that's equal to 0. Bring the 3 down. Now, if I was just asked to factor, I'd be done right now, but I wasn't. I was asked to solve. Here's where I tee it up, and this one has 3 different factors, so it's a double tee it up. Underneath each section of your T, you're going to set your factors equal to 0 and solve each one. 3 equals 0 has no x to solve for, so it's nothing at all. It just goes away. For this one, I subtract 2 from both sides, and I get an answer of negative 2. For this last one, I add 8 to both sides, and I get an answer of positive 8. If you recall, if I were to graph my original function that's equal to 0, it would cross my x-axis at negative 2 and 8. That'd be a really, really quick check. You'll also get negative 2 and 8 as answers if you use the quadratic formula. The quadratic formula just has really, really big numbers, but they're doable as long as you use your calculator and you are careful with your signs. Okay, so number 11 was a quadratic because of the x squared. Okay, moving on to number 12, if I look, there is no x squared, there's no x in the exponent. This is just a simple linear equation, like what we started with, those basics. Okay, for a linear equation, This one has two different x's and they're on opposite sides of the equal sign, which means I need to move one of them over to the other side by doing the opposite. I always advise that you move the smaller of the two, so between a 4x and a negative 6x, negative 6x is smaller, so I'm going to add 6x to both sides, getting it to cancel on the right side. 4x plus 6x is a 10x, and everything else is going to come down. Now, I don't know if you remember, but this is that home base form that we talked about so much in the beginning of the semester. To get x by itself now, I'm going to add 7 to both sides, and I get 10x equals 20. And then to get rid of that 10 that's being multiplied to the x, I'm going to divide by 10, and I get x equals 2. Number 13. Take a second to look at it and try and figure out if it's linear, quadratic, or exponential. You need to be able to decipher between them in order to figure out which method to even use. And hopefully, you decided that it was linear. It just has x's in it, no x squareds and no x's in the exponent. However, for this one, it's a little bit of a trickier linear one than number 12 was because I have the distributive property, and I have the distributive property twice. So first I'm going to distribute the 2 through 2 times 3x, 6x, and 2 times 2 is 4. Then I distribute a negative 4 through. Be very careful with that. Negative 4 times x is a minus 4x, and negative 4 times negative 6 is a positive 24, and that's equal to 30. Now, similarly to number 12, this one also has two x's in the same problem, but they're on the same side of the equal sign. When that happens, all you do is combine them. 6x minus 4x is 2x. And then I'm also going to combine these constants, or these numbers. 4 plus 24 is a plus 28, and that's equal to 30. And boom, I'm in my home base form. So now I'm just trying to get x by itself. You always get rid of what's being added or subtracted first. So I'm going to subtract 28 from both sides, and I get 2x equals 2. How nice is that? To get rid of that last 2, I divide both sides by 2 so that these cancel, and I get x equals 1. 2 divided by 2 is 1. Now remember, every single one of these can be checked by taking the x value and plugging it back into your original to make sure the left side equals the right side. All right, take about a second to look at number 14 and figure out if it's linear, quadratic, or exponential. Hopefully you said exponential because there's an x in the exponent. So this one is exponential. Just gotta give my pen a second to catch up with me. Exponential. Okay, now this one, for exponential, guys, we learned two different ways of solving it during class. There's common bases and there's logs. Okay, I'm going to show you common bases real quick, but I know a lot of you prefer logs. So for common bases, the reason that I know that common bases can be used for this one is because 16 can be rewritten with a base of 2, and the left side has a base of 2 already. So that 2, woo, let's fix that. Okay. So that 2 comes down, 2 to the 3x plus 7, and 16 can be written as 2 to the 4th. I didn't change anything. 2 to the 4th is equivalent to 16, but now that I've written it like that, they have common bases, and my common bases method, gone. I'm just going to label this common bases. If you don't like this, then don't do it this way, okay? But my 2's eliminate now that they're common, and your exponents come down. 3x plus 7 equals 4, and you're in that home base linear form. So I start by getting rid of being what's being added or subtracted first. To get rid of that plus 7, I subtract 7 from both sides, and I get 3x equals negative 3. And then divide both sides by 3, I get x equals negative 1. Now I'll show you logs. For logs, remember I'm using logs because it's an exponential function. You start by writing the word log on both sides. So the log of 2 to the 3x plus 7 is equal to the log of 16, and the whole point in taking the log was so that this 3x plus 7 could come down in front. So 3x plus 7 comes down, and that's times the log of 2, and that's going to be equal to the log of 16. Now, then I get rid of the log. Now that I've brought that exponent down, I'm going to get rid of this log. Now the log is being multiplied, so I'm going to divide by the log of 2 to cancel it out. So then on the left side, 3x plus 7 is going to come down, and I plug in the log of 16 divided by the log of 2 in my calculator, and it gives me 4. be a nice number. And then hopefully you notice that this is the exact same as this step right here. So logs is a little bit longer. I think it's a little bit less challenging in the beginning to try and figure out what bases work, especially if you're not so great with knowing your powers. If you didn't know that 2 to the 4th was 16, that method would be harder. So at this point I subtract 7 from both sides, just like I did before, and then divide by 3. I get x is -1 anyway. All right, next page. Number 15. You try and figure out what type of function it is to start. It has an x squared in it, and that tells me that this is a quadratic. Now, we talked about it on the last page. Let's try and spell that again, shall we? Quadratic. Perfect. We talked about it on the last page that you must be equal to 0 in order to solve this, and I'm not. So to get that positive 18 to the other side, I'm going to subtract it over. And I also need to write my terms in the correct order, which means this 2x squared comes down first, then a minus 6x, then a minus 18, and now I'm equal to 0. Now, I'm going to change up my pen to red. I don't want you to write what I'm about to write in pen, but this is for my factoring lovers. All of you love factoring, I know. Okay, I would start by GCFing and taking a 2 out. Okay, so this is 2 times x squared minus 3x, minus 9. And that's equal to 0. So this one, unfortunately, does not keep factoring, and here's why, and here's also why I didn't want you to write out the red. It's an easy trinomial that's left in here. So off to the side, I need to find the factors of 9, which is 1 and 9 and 3 and 3, but I'm supposed to pick the pair that adds to 3, and there is no pair that adds to 3. So factoring doesn't work for this one. Now, if you're the kind of person that just prefers to use the quadratic formula no matter what, you might have lucked out on this one because you wouldn't have had to do that extra work. Now, this board has had enough for today. All right, let me just rewrite that real quick. I have 2x squared minus 6x minus 18, and that's equal to 0. So again, factoring did not work, so I have to use the quadratic formula, which will be given to you, and it is on the back of your review packet on the formula sheet. So the formula for the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, and that's all over 2a. In order to use the quadratic formula, you need to know what a, b, and c are, and they always go in the right order, a, b, c, as long as you've written it ax squared plus bx plus c. So a for this problem is 2, b is -6, and c is a -18. So now I go ahead and I plug it in. So I bring down the x, I bring down the equals, and I bring down the negative. Now b is a -6, so I'm going to write -6, keeping in mind that that negative in my next step is going to become a positive. Next thing I see in my formula is a plus or minus, so I bring that down, and then I bring down the square root. B is a -6, and I put it in parentheses, so it's -6 squared. Then I have a minus 4 times a, which is 2, times c, which is a -18, and then it's all over 2 times a, which is 2. Now, if you have the TI-84 or higher, I'm going to show you a shortcut that might work on your calculator that's absolutely worth a try at this point. So in your calculator, what you can try to do is hit alpha, y equals, enter. If this fraction looking form comes up where there's a box over another box, you can type it in exactly how you see it right now, and I'll show you that real quick. So it's a 6. You have to do it plus and minus still, but it'll be 6. I'll do the plus first, plus. I type in the square root, which is second x squared of, there's parentheses, -6, parentheses, squared, okay, minus 4 times 2, parentheses, times -18. See how that's all underneath this really long square root, just like it is in the formula. And then I hit the down arrow to get to the bottom, and then 2 times 2 is 4. If you press enter, you end up getting one of the decimals that you should get if you do it the long way that we did in class. This is only a shortcut if the alpha y equals enter works in your calculator. If it doesn't, I'm going to show you how to do that in a second. I'm just going to continue with my shortcut, people. If this worked for you, what you can now do is, because I also have to do 6 minus blah, blah, blah. So I'm going to go up, highlight over it. I hit the up arrow to get up there. Press enter, and notice it copies and pastes it for you. So you're going to scroll all the way over, hitting that left arrow to that plus sign that I need to change. Change it to a minus, hit enter, and that's your second answer. So if you have the alpha y equals enter trick, memorize it and practice plugging it in so that you have a good idea of how to do it when the test time comes. If you don't have the alpha y equals enter option on your calculator, here's how you are supposed to simplify this in your on your paper first so that you can plug it into your calculator. You're going to do this piece first. Okay, so this is going to come down as x equals, it's a positive 6 now, plus or minus the square root of, when you simplify that negative 6 squared, it is a positive 36. Then you're going to do in your calculator, negative 4 times 2 times negative 18. If you type in negative 4 times 2 times negative 18, you get a positive 144, so you write plus 144. Just backtracking for a second, if you did this red circle right here, negative 6 squared in your calculator, and you got a negative 36, it's because you didn't put it in parentheses. If you're squaring anything in your calculator, you should always put it in parentheses, but especially when you have a negative, just be careful about that. Okay, and then that's all over 2 times 2, which is 4. So now I'm just going to do 6 plus or minus the square root of 36 times 144, plus 144 is 180, and that's over 4. Now you're at the point where you're going to plug it in. There's 2 things that you plug into your calculator. The first one is going to be 6 plus the square root of 180 over 4, and the next one is going to be 6 minus the square root of 180 over 4. Now when you plug it in, and I'll show you how to do it in the calculator in a second, you're supposed to type in the top first, 6 plus the square root of 180, then press enter, then divided by 4, enter, and the same thing for minus. So here we go. In the calculator, I'm starting with a clear screen. You would type in 6 plus, again to get the square root, you hit second, x squared. See the little square root symbol above the x squared? It's in blue. That tells me to hit the blue key first, and then the square root comes up, and under it I type in 180. Then you press enter. That's not your answer. You hit divided by 4, enter. That's going to be one of your decimals. Then you do it again with a minus. 6 minus the square root of 180, enter. Divided by 4, enter. There's the other answer. Okay. Now, in the directions it said to round to the nearest tenth if necessary. I'm just going to copy these decimals down first. I'm running out of space up here. It was 4.854102 when I first did it, and negative 1 point. I know your decimals were a little bit longer on your calculator. I'm just copying it from my key at this point. Okay, but I have to round these to the nearest tenth, which would be 4.9. Remember, you look at that second digit after the decimal point to see if that rounds up, and the 5 does. Give it a shove. This one's a negative 1 point. Again, that 5 bumps that 8 up to a 9. So 4.9 and negative 1.9 are my answers. All right, now I'm going to move over to number 16. 16 is not a quadratic again. This one's going to be exponential because of the x in the exponent. So exponential. So I have 5 to the x minus 4 equals 275. If you tried to do common bases for this one, it would not work. 275 cannot be written with a base of 5, because if I try, 5 squared is 25, that doesn't work. 5 to the third is 125, that doesn't work. 5 to the fourth is way too big, 625. There was no power that 5 could be raised to get me 275, so logs are a must for this one. So I start by writing the log in front of both sides. So log of 5 to the x minus 4 is equal to the log of 275. Now the point of me taking the log of both sides point of me taking the log of both sides was so that that exponent, x minus 4, could move to the front. So x minus 4 comes in front of the log of 5. That's equal to the log of 275. But just like all the other log problems that we did, I have to get rid of this log of 5 so that I can get the x by itself. They're being multiplied, so I divide by the log of 5. Divide by the log of 5. Except x minus 4 comes down, so I'm not completely done. I'm just getting there. The log of 275 divided by the log of 5 when I plug it in my calculator is going to be 3.489896. I'm done with the logs now, but to get x by itself, I have to get rid of that minus 4, and to do so, I'm going to add 4 to both sides. So I get 7.489896. Look at the second place after the decimal point to see if it bumps that first place after the decimal point up, and it does, so my answer is 7.5. That looks like a lot, doesn't it? Ooh. All right, number 17, try and figure out what type of function it is based on its setup. 17 has an x in the exponent, so it is also exponential. Now, I'm just going to jump up back to number 16 real quick. For 16, if you notice, it started with the 5 raised to the x minus 4, but the 5 was by itself, and it has to be in order to take a log. For 17, the 1.02 is the only thing that's being raised to that x over 12 because it's in parentheses. The 500 is not being raised. So I can't start taking the log of both sides until I divide both sides by that 500. And I divide because the 500 is being multiplied by the 1.02 to the x over 12. So when I divide that 500, it cancels over here, and I just have 1.02 to the x over 12 equals, when I divide those in my calculator, I get 4.6. Now that the 1.02 is by itself being raised to the x, I can take the log of both sides. So the log of 1.02 to the x over 12 is equal to the log of 4.6. Now remember, your whole point in taking the log of both sides was to get this x out of the exponent. So it comes down in front as my next step. X over 12 times the log of 1.02 is equal to the log of 4.6 just comes down. Now the same step that I just did in number 16 was get rid of the log. It's being multiplied. So to get that x closer to being by itself, I have to divide by the log of 1.02. Divide by the log of 1.02. So the x over 12 comes down, and the log of 4.6 divided by the log of 1.02 needs to be plugged into the calculator. When you do that, you get 77.063325, which is not your final answer because that's solved for x divided by 12. I have to get rid of that divided by 12. To undo dividing by 12, I multiply both sides by 12. Now in your calculator, it's already stored that number, 77.06, blah, blah, blah. So all you have to press is times 12. It'll say ANS times 12, it's just plugging in your answer. And when you do that, you should get 924.7599. Look at that second number after the decimal point to see if that bumps up, and it does bump up, so this is 924.8. You only look at the second place after the decimal point to see if it bumps that first place up. You're never going to round these questions that say round to the nearest tenth to that place, so be very careful about that. This one's 924.8. I also want to mention that at that step where you had the 77.063, you don't want to round at that step. You always wait until the very, very, very last step in order to solve. In order to round. All right, number 18, last one in this 11 through 18 set. Try and figure out what type of function it is. I'm going to switch up my color just because I'm sick of looking at blue. It's a quadratic. It's a quadratic because of the x squared. So since I'm solving a quadratic, I know that my setup needs to be equal to 0. I'm going to subtract 1 from both sides. And notice I put it under the -8 because for this one, that -1 will combine to the -8. When I bring everything down. So first, the 4x squared comes down, then the plus 4x, and a -8 minus 1 is a -9, and that's equal to 0. If you are one that likes to try and factor it first, go for it. Trust me that this one does not. If you don't trust me, look back at my key. I show you how it does not factor. This one you must use the quadratic formula. So for the quadratic formula, you need to figure out what a, b, and c are. A is the number in front of x squared, which is 4. B is the number in front of x, which is also 4. Be careful with c. It's the number that's by itself. It's a negative 9. Okay. Then I go to my formula sheet, and I copy down the quadratic formula so that I can plug these numbers in. Again, you don't need to memorize that. It's on the formula sheet. When I go to plug these numbers in, I bring down the x, I bring down the equals, and I bring down the negative, and I'm going to plug in b now. B is 4. Then the plus or minus comes down, and so does my square root. Now I'm going to plug in a 4 again, squared, minus 4 times a, which is 4, times c, which is negative 9, and that's all over 2 times 4. So if you were the kind of person with the calculator that had the shortcut, at this point, try plugging the shortcut into your calculator. It might benefit you. If you don't have the shortcut, stick with me so we can simplify it together. Okay. The x equals negative 4 plus or minus comes down, and so does your square root symbol. You square that first number first. So 4 squared is 16, and I'm all set with that. Now I need to do in my calculator negative 4 times 4 times negative 9. Well, negative 4 times 4 times negative 9 is 144. So I write plus 144 because it was positive. Okay, now that's all over 2 times 4, which is 8. Now I'm going to add together those numbers under the radical, so negative 4 plus or minus the square root of 16 plus 144 is 160, and that's all over 8. Here is where you split it up. First you're going to plug in negative 4 plus radical 160 over 8. Then you're going to type in negative 4 minus radical 160, the square root of 160 over 8. And remember, you type the top in, then press enter, then divided by 8, enter. Same over here. Type in the top, enter, then divided by 8, enter. And here are the 2 decimals that you should get when you plug them in. First is 1.081139. And your next one is negative 2.081139. Again, mine might be rounded a little early. It's just because of the calculator setting on mine. When I round this to the nearest tenth, I look 2 places after the decimal point. That 8 does bump that 0 up, so one of my answers is 1.1. And then this next one, again, the 8 bumps that 0 up to a 1, and my other answer is negative 2.1. Make sure you know how to determine which type of function you have, so you know which method you're supposed to use and know how to use each method. There's a lot of thinking involved in these questions. All right, next. Graph h of t equals negative 16t squared plus 112t in the following grid, where h of t represents the height of a rocket in feet over t seconds. So the height is going to be your y-axis. Seconds is going to be your x-axis. Now, to graph a parabola, and I know this is a parabola, again, because of that t squared, I have to plug this into my y equals. Now, there's a problem. We've never plugged a t into the y equals. That's okay. All you're going to type into your y equals is an x instead. So negative 16x squared plus 112, x. In your calculator, just type in an x instead of a t. Now, if you hit graph, these numbers are way too big to actually be seen on your 10 by 10 grid. What that means is you're going to have to look at your table to pick out the specific points that can be graphed. Now, if you look at the grid that's given to you, it's only one quadrant, and what that means is you can only graph positive values. Your origin is this down here. That's your 0, 0. You can only go to the right and you can only go up from there. So you can only plot positive values, which makes sense because we're talking about seconds. You can't have negative time, and we're talking about height, and you can't have negative height. So what you're going to do is go to your table, so hit second graph, and copy down the values that can be plotted. So here's the graph that you should get. Here's your table over here. I just copied it straight from the second graph in my calculator, and I only wrote down the positive values. Then I took those points and I plotted them. Now, on your axes, you're not scaled. So I already have the graph up here. I'm just going to explain to you how I came across my scale. So looking at the table, my x values go from 0 to 7, which means my x-axis needs to be scaled from 0 to 7. And it is. I just went every 4 boxes, counted as one number. The reason that I did that was to spread out my graph. It's easier to see your graph if it's spread out. If you just did 1 through 7 on the first 7 boxes, your graph would have only been in those first 7 boxes, and the whole rest of the grid would have been blank, and it would have been harder to read. So try and spread it out as much as you possibly can and use what you're given. Take advantage of the space that you're given. The y-axis, in my opinion, is a little bit trickier because if you look at your y column on your table, it goes from 0 all the way up to 192, which means that on your graph, on the y-axis, you need to scale it from 0 through 192. Found out later, or after doing this, that the best thing to count up by was 16s. But counting up by 16s, personally, in my head, not so easy, but you could do it in your calculator. I counted up by 20s. Okay, 20s is a more common thing to count up by, only because it's, it ends in 0. 20, 40, 60, 80, we can count up by 20s real quick, and it fits that way. Counting by 10s would not have fit. So that's why I scaled my x and y axis the way that I did, and then I plotted it as so, and I knew it was a parabola, so when I connected it, I made it U-shaped, meaning that between 3 and 4, where they were both at 192, it goes a little bit higher in between there to make that curve happen. It's not a flat plateau at the top. Notice that there's a little bit of a curve right here. Oops, 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 oops. You see how it curves just a little bit higher in the middle there. So pause it to get that plotted. If you need more time, I'm going to move on to part B. So B says, at what time does the rocket reach its greatest height? Well, the greatest height, like we just said, at 3 and 4 were the highest on the table, which was 192, but halfway between them is where it hits the greatest height, and halfway between 3 and 4 seconds is 3.5 seconds. Part C, at what time does the rocket reach the ground? Well, it goes up, 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 and then it comes down, 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 and boom, at 7 seconds, it reaches the ground. I'm hoping that sounds a little bit familiar to you. A previous problem, I don't remember at the time what number it was. Give me a second to look back. Number 9. We solved this algebraically, and we got the same answer, 7 seconds. Now we're just doing it graphically. Remember, your solutions are where the graph crosses the x-axis. So 7 seconds is where it reached the ground. And then part D says, through what time interval is the rocket decreasing? That's where the graph is going down. So if I go back up to my graph, notice in blue, it started decreasing at the highest point, and then it went down, 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 down until it reached the ground. So my interval for where it's decreasing started at 3.5, and it went through to 7. 7's where it stopped decreasing because it hit the ground at that point. Ooh, one more question. All right, here we go. Number 20. Okay, 20 is something that we just did recently as well. It's exponential regression. So it says water is flowing out of a reservoir such that the depth of the water is a decreasing function of the number of hours since the water was released. Engineers measure the depth of the water, and the results are shown in the table below. So you don't have to worry about the fact that they recorded all this data. All you need to know is which one is X and Y, and they're labeled for you. X is on top, Y is on the bottom. Okay, A says, find an exponential equation that best represents the data above using exponential regression on your calculator. Round your coefficients to the nearest hundredth. So the numbers that pop up in your calculator need to be rounded to the nearest hundredth, which means 2 places after the decimal point. So I'm going to show you how to do this. Again, in my calculator, I'm sorry that it's sideways. It's just the way that my phone's set up. I can't really turn my calculator. I know it's also probably upside down. I don't really know. Just try and turn your head and do the best you can. I'm very sorry. Okay, but I do want to point out that the step-by-step is given right here. The step-by-step will also be given to you on the test. So as long as you're able to follow those steps, you'll be able to get this question right on your test. So the first step says press stat. So stat is this button right here, stat. And then it says edit. So edit is right here, choice 1. I'm just going to press either 1 or enter, and it'll bring me to this page. If you have numbers in your columns or in your lists, here's how you clear them out. You scroll up to L2 or L1 or whatever you've got, hit clear, and then press enter. Do not press delete or your list will go away completely. If that happens to you while you're trying to study, please email me and I'll walk you through how to get rid of it. Or YouTube is your best friend. It'll help you through anything. Okay, to get over to that one, I just press the right arrow and then the up arrow. So I'm highlighting over L1 and I press clear, enter again. And you should have completely empty lists in your calculator. So that was step 1. Now step 2 says to enter your X values in L1. Ooh, that made it blurry. And enter your Y values in L2. Ooh, that was weird. All right, so my X values are going to go in L1, so it's 2, enter, 4, enter, 8, enter, 14, enter, 20, enter. You're going to want to be very, very, very sure that you plug these numbers in correctly and don't accidentally press, I don't know, like 9 instead of 8, because it'll mess up your entire problem and you can't get B and C right if you get part A wrong. So please be cautious and double check that you plug them in right. So I'm on step 3, plugging the Y values into L2, so be careful with these, especially because they're decimals. So 44.7, enter, 36.8, enter, 29.2, enter, 22.3, enter, and 15.1, enter. So again, double check at this point that you've plugged them in correctly, just so you make sure you're all set. Okay, now that was steps 1, 2, and 3. Now step 4, just like we did with linear regression, but now it's exponential regression, we're going to press the stat button, go over to calc, and then instead of pressing choice 4, which was linreg for linear regression, we're going to go down to choice 0, which is expreg for exponential regression. Okay, so in my calculator, I press stat, I go over to calc, and I go down, 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 down until I get to choice 0, which says expreg, and I press enter. Now, if your calculator shows up like this, it just means you have to press enter about 4 more times. If it didn't show up like this, you only have to press enter 1 more time, but ultimately you're going to just press enter until you get to this screen. If your R value did not show up, don't worry about it. That was important for the linear regression, and it is important for exponential as well, but we're not going to have a question on it on the test. So all you really need is Y, A, and B. So what you're going to do at this point is copy down Y, A, and B on part A. Okay, so I'm going to write Y is equal to, now it says A star B caret X. What that really means is A, that star means time, so I'm going to use parentheses, and then that caret means it's an exponent, which makes sense because this is exponential functions, exponential regression. So that's really what that's coded as. I would write it like this to help yourself out. Like really, really, really study this and make sure you write it like this instead of the way that it's given on the calculator, which is Y equals A star B to the X. Write it like this instead. Okay. Now I'm going to write out A. A is 47.96967098, and B is 0.9442414,217. Okay, now I'm on step 5 right now. When I press enter, it says substitute values into your equation and have them rounded. Now it told me to round to the nearest hundredth, which we said in the beginning of the problem is 2 places after the decimal point. If I'm trying to round to 2 places after the decimal point, that means I need to look at the 3rd place after the decimal point to see if that will bump up this 2nd place. For A, it does. So A is going to be 47.97 because the 9 bumps the 6 up to a 7. B, if I look at the 3rd place, it's a 4. 4 does not have enough power to bump that up, so B is just going to stay 0.94. But notice I have 2 places after both decimal points in both A and B. And I'm still not done. Right now I'm at this substitute part. So now that I know that A is 47.97 and B is 0.94, I'm going to substitute them in. My final answer is going to be green. So it's y equals, in place of this a, I'm going to plug in 47.97, bring down the parentheses, plug in b, 0.94, and that's raised to the x. All right, now part B. Part B says use the equation that you got in part A to predict the depth of the water after 48 hours, days. It should just say hours. Pretend that days is not there. Have elapsed. Round your answer to the nearest tenth of a foot. Well, 48 hours, if I go back up to my table, hours was x. So what this question is telling me is that x is 48, and I need to figure out the depth of the water. Well, the depth is y. So what I'm going to do is, in my formula, y equals 47.97 times 0.94, I'm going to replace x with 48. That's all I got to do, and plug that into my calculator. So you're going to type in 47.97 times 0.94 caret 48. When you plug that in, you should get 2.460972106, which rounded to the nearest 10th. Now I look to the second place, see if it bumps that first point after the decimal point up, and the 6 does bump it up to 2.5, and it's going to be 2.5 feet. All right, part C, last question. Sorry if I'm going quick. My battery's about to die, and I don't know if it's going to delete the video, which would be really upsetting because I'm an hour and a half in. Okay, so C says use the equation again from part A to estimate the time x. So now I'm solving for x in hours that the depth of the water was at exactly 30 feet. So the depth, if I go back up to my table again, just a reminder, it says that depth is y. So if it's telling me that the depth is 30 feet, it's telling me that y is 30. So in this equation that I got in part A, I'm going to plug in 30 for y and bring down the rest, 47.97 times 0.94 to the x. Now this looks a heck of a lot like an exponential function that needs to be solved because x that I'm looking for, that I'm trying to solve for, is in the exponent. Now I can't solve this with logs like I'm supposed to until the number that's being raised to the x is by itself. Now the 0.94 is the number that's being raised to the x. To get that by itself, I have to get rid of the 47.97, and they're being multiplied. So I start by dividing both sides by 47.97 so that these cancel. Now in my calculator, I don't get a nice number, but you gotta write the whole thing down. You never round until the last step. 30 divided by 47.97 is 0.625390863, and that's equal to 0.94 to the x. Now that I've gotten the 0.94, which is what's being raised to the x by itself, I'm able to take the log of both sides. So I write the log of that whole decimal. Guys, do not round that early. On your test too, do not round it early. 0.625390863, just making sure I copied it right. And that's the log of 0.94 to the x. Now the whole point in taking the log of both sides was to move that x to the front. So this is going to become, again, the log of 0.625390863, and now that's equal to x log of 0.94. And thank goodness I am almost done to get x by itself. Well, the x is being multiplied by the log of 0.94, so I divide by the log of 0.94 on both sides. Yes, you have to type in this whole decimal in your calculator. So when I type in the log of 0.625390863 divided by the log of 0.94, again being careful with my parentheses, I get 7.585864,587, and it asks me to round to the nearest tenth. So I look at the second place after the decimal point because tenth means one place after the decimal point. And that 8 bumps the 5 up, so x is equal to 7.6, and that's going to be hours, meaning that it takes 7.6 hours for the depth to reach 30 feet exactly. Okay, so if you need extra help, please email me. Please come to those office hours. Please come to the optional review class if you have questions. If you also just want to go back and rewatch a couple of these questions again, by all means, best of luck studying, and I will see you on test day.